Hey everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch. I'm a developer advocate here at AWS, and this is our weekly show where I bring on guests to talk about a specific topic and let you, our viewers, ask your questions and get any question you like answered by me and my guest. And this week I'm joined by Prasad Rao, and welcome to the show, Prasad.
Thank you, Gunnar.
So this week we're going to talk about modernizing legacy WCF applications to core WCF using Porting Assistant for .NET. And there's a lot to cover in that title only. So Prasad, to begin with, tell everyone a bit about yourself.
Sure. So I'm a partner solution architect here at AWS with AWS around 2 years now. And I specialize in migrating and modernizing Microsoft workloads onto AWS.
So welcome to the show then. And well, let's jump back to that title or what we're going to talk about that I mentioned. And I think we need to cover what all of those things are.
Right.
So first off, when we're talking about legacy WCF applications, what are those?
So yeah, even before understanding WCF applications, let's talk about the legacy .NET applications. So WCF applications are a specific type of .NET applications. So let us first talk a bit about the .NET framework applications. So .NET framework, it all started in 2002 when Microsoft released the first version of .NET framework. And they kept enhancing it, with multiple releases over a decade. And till 2012, they kept releasing multiple versions for .NET framework. It was one of the widely used, a framework for developers developing applications on Windows platform. So .NET framework was proprietary and it was only working on Windows platform. In 2012, Microsoft thought that they should invest more in open source. And then they started working on open source cross-platform version of .NET, which they call it as .NET Core. And that was released in 2016. So first release of .NET Core was released in 2016. And from that, it enabled the developers to develop applications in .NET, but deploy it and run it on Linux platform or other platforms. And it is open source. So we have a .NET Foundation, which is an open source community, and developers are able to contribute to it. So yeah, that's about the history of the .NET.
Yeah, and I mentioned to you before when we talked about this topic that feels like 2012 just feels like a few years ago for me that .NET framework was a thing, but .NET Core then has been the option for developers using .NET now for quite a few years.
Yes, and Microsoft is and the overall open source communities is enhancing it quite a lot. So we had .NET Core 3.0 released in 2019 around, and after that Microsoft thought it is time to almost retire .NET framework. So they released just one minor version for .NET framework, which is .NET Framework 4.8, and now everything going ahead will be only on the .NET. And now they have unified it and they call it as .NET, not a framework or not a core. So they now call it a normal .NET, and which is going to be an open source cross platform. And they released .NET 5 last year, 2020. But it is not a long-term version release. So they are releasing .NET 6, which is going to be the long-term version. So yeah, all enhancements would be going forward will be on .NET. And that is why it is interesting for our customers, right? Most of the enterprise customers do have a lot of .NET framework legacy applications. I have built quite a lot of .NET framework applications for financial customers before joining AWS. And now this is the opportunity for customers to modernize them onto the newer version of .NET and potentially save a lot of cost by running them on Linux platform, right? So yeah, performance wise it is better. You can use the ecosystem of the entire Linux, and from the cost perspective you are going away from the Windows Server licenses.
What are the customers the typical customer using .NET applications? Is it enterprises, or do you see it across different verticals and different type of companies?
Now, like I see whenever it's adopted initially, Microsoft has good penetration into enterprises, right? So that is why it was like more adopted by enterprises initially. But now I see .NET is being used widely across, like even the startups to mid-sized companies, they use .NET quite widely. And like there are case studies in which customers have actually like modernized their .NET framework applications to .NET Core and run on AWS using containers, like and cloud native alternatives.
Right. So then, well, let's get to what we're actually going to do in this episode when we've covered a bit of the context. So what are the ways to then modernize your applications?
So, okay. So when you have a .NET framework applications, it depends upon, application to application. You have several ways to modernize them, right? Uh, if you talk about when, applications were developed a decade ago, there was more of a monolithic constructs, right? A lot of the applications which are developed were monolithic. Now, while modernizing them, you not only like port them from .NET Framework to .NET Core, but also try and deconstruct that monolith into microservices and have these multiple .NET Core or like .NET 5 microservices which can run independently. And we all know the benefits of like having microservices architecture over the monolithic, that in terms of the elasticity, scalability, and independent, like without the tight coupling that it provides. So that's where I see like the most of the industry moving towards that. They are modernizing their monolithic applications to the microservices and try and run them on more cloud native toolings, whether it is serverless on Lambda or having the containerize them and running on ECS or EKS.
So then we get to what is called porting assistant
Right.
for .NET. So tell us a bit about that.
Sure. So when we talk about like as I said, like Microsoft last major release for .NET Framework was in 2012, and then they like took 3 or 4 years to release .NET Core, which is open source version. Now customers, when they would like to port their .NET Framework applications to .NET like Core, the problem with it is that not all APIs or the NuGet packages which are core for the .NET are compatible with .NET Core. Means that there are like packages which were tightly bound to the Windows platform, and you will not be able to use them as it is in the open source version, right? And that is why the overall porting a .NET framework application .NET Core is hard. And this is where like the customers are investing a lot of time. And that's when like we at AWS thought about how we can make this overall journey simpler for our customers, right? We understand that the customers want to modernize their legacy applications onto AWS using cloud native like tooling, but we would like to like reduce the overall like resistance that customers had, that this whole will require a lot of like effort from their side. And that's when we released a porting assistant for .NET, which is a way to assess your current .NET framework application. So yeah, if you'd like to share the screen, probably I can start showing the overall tool along with it. So yeah, this is like porting assistant for .NET. Or before that, let me go on to the home page for porting assistant for .NET. Yeah, so this is the porting assistant for .NET homepage, and we released it in July last year, the first version, which actually allows like customers to assess their existing .NET framework applications and like see how much effort it would be requiring for like porting it to .NET Core. And then later in the year, we also introduced something called a CTA, which is code translation feature, in which we have tried to find the common patterns in the .NET framework applications and have written rules which will help them to make those code changes automatically. So mainly, if we see from the benefits perspective, it first of all, like because we are able to assess the overall. So let's say if our application, and we look into that, during the a quick demo also. Let's say if our application or a solution file has 25, 30 projects, right? It's a large application. Then in what, a phased manner, you should be actually starting to modernize them, right? So the overall assessment helps you to see, what are the low hanging fruits which you can start targeting and start modernizing. So you can, create the, understand the overall effort and create that overall plan, right? And then even while porting, you are able to reduce the overall manual effort, because the porting assistant, what it does is that it identifies the common patterns uh, of, what a .NET framework equivalent looks in .NET Core, and it goes ahead and make those changes, on its own. Obviously, it shows whether you would like to make the changes or you would like to, do it on your own, and you can choose accordingly. And then, it makes the code changes on your behalf. So yeah, that's the overall high level view of porting assistant. But if you would like to, sorry,
Yeah,
go ahead.
yeah, and Porting Assistant, it's a standalone application, so it's not something that you're running in the console, for instance, as people might be used to.
Right. So porting assistant is available currently in two versions. One, it's a standalone application that you can install on your Windows desktop. And secondly, later in the year, around November, I believe, last year, we released uh, a Visual Studio plugin. We did an extension for the Visual Studio for the developers who would like to remain in their development environment and start porting. So it is available within the Visual Studio as well as a standalone tool. There are bit, features which are more available in the standalone tool, and we'll look into that. But when it comes to more developer friendly, we show like all the incompatibilities in the warning sections within the Visual Studio itself. So it depends upon, developers how they would like to, use the whole experience of porting assistant.
All right. So should we have a look at the application, or what do you want to do next, Prasad?
Yeah, sure. Yeah, just before that, before we dive deep into the application, overall how it works, this is something that we
Yeah.
discussed briefly right now. But again, it all starts with, assessing the current, application, which is, when you open the standalone tool and provide it a solution file. It requires a solution file to assess the entire code base, and it scans it through, the overall code file, and finds the, APIs and NuGet packages which are compatible and not compatible, and shows that. When the assessment is done, you can always export that assessment, and then you can think about, planning your whole project of how you would like to, go on individual projects. And finally, as I said, we do have an option for assisted porting, in which we use the feature called code translation assistance. And we can dive deep into it during the demo. But yeah, as you said, let's go to the tool.
Right. And to begin with, since this is a standalone application, there's one feature missing that we talked about before we went live.
Yeah.
And
It's like, we are not able to zoom it, yeah, I'm not sure if how well readers are able to read this. Is the font size okay or not? But yeah, this is something that, working with service team to have that feature is to have the ability to zoom it or something like that.
yeah, but we'll walk through every part and you'll explain it, so
Yeah,
they'll be able to follow along.
cool.
All right.
So when
So
we first,
the
sorry, go ahead.
UI, yeah, the UI is very familiar. It looks a lot like something in the AWS console. So
Yeah.
that's good start.
So yeah, when we first install, this is the homepage that comes about. We have this get started button here, which can, and even for downloading this, let me go back here, and you can download it from the homepage of the porting assistant, and then just install it. It's just a MSI which can be installed. And then when you first open it, this is how it looks like. It also lists all the, benefits and features here. Yeah, which we, anyways discussed. For the first time, when you would like to assess a particular solution, it'll ask you to provide some mandatory settings, right? So let's look into that. If I click on edit here, the first is the target framework. So I said .NET Core currently. So your source file would be in .NET Framework, but your target can either be .NET Core or .NET 5. So we have two releases right now, and .NET 6 will come later this year, like probably around mid-November. .NET 6 would be coming. Then we'll be adding support for .NET 6 too. But right now, customers has options to port their .NET Framework application to either .NET Core or .NET 5. I'll keep it as .NET Core because .NET Core is the long-term version release. Yes.
So even though it's a different name, it skips a bit of versions. .NET 5, it is the following version basically, and then we'll have number 6, which will have long-term support again.
Yes.
Yeah,
that's right. Cool. And the second is mainly, this is the CLI credentials that we provide, AWS named profile that we need to provide. So I have it configured as my own, like a CLI profile, and I configured it. So this is how you access the AWS account. It is mainly needed, like for sharing, a bit of the usage data and getting the information about all the, common patterns which is used to analyze and assess the overall data. If the customers are not comfortable in sharing that usage information with AWS, they can always uncheck this. Cool. That's on the settings part. And once the settings is saved, you can always go to assess solutions. I already assessed one particular solution, NOP Commerce. When we'll do a demo of a specific WCF application, we'll go ahead and do a assess solution. But first, I would like to show more of the features with one of the solution that I've already assessed at. So NOP Commerce is an open source e-commerce project, actually. The latest version of NOP Commerce is already in .NET Core, but I have used version 3.8 release of NOP Commerce, which is in .NET Framework 5.0. So this particular, when we assess it, this is how it shows the overall information, right? The number of ported projects. So this NOP Commerce as a solution has 35 projects in it, right? And there are 0 projects that are ported. So while porting, we do have option to port, like all the projects at one go, or like select few of them and project it like in a sequential manner. The number of incompatible packages. So this is where like overall the number of packages that are being used. When we say packages, these are NuGet packages that is used in the .NET world. So there are total 56 NuGet packages that are being used across the 35 projects in the overall NOP Commerce solution, out of which 52 are incompatible. Right. So you see there are a lot of changes, though it is all .NET, the code writing style is same, but the underlying packages are quite different.
And I know this is a typical it depends question, but is that common that you'll end up with that many incompatible packages?
It depends. The answer is exactly, it depends. Right. So yeah, it depends upon how complex this application is. For example, NOP Commerce is a quite big and complex application, right? So when we will show a demo of full end-to-end porting, I'll be using a very simple basic WCF application that might be having a lower level of incompatibilities.
Yep.
Right. Then we have incompatible APIs. The ratio is a bit better, like 1395 APIs overall versus 451 incompatible.
And those are APIs within, in this case, .NET Framework,
yes,
that are incompatible with the newer .NET Core.
Right. Those are internal APIs that are being called within these packages and the source code that are incompatible. Build errors. This shows that in case if your current .NET Framework application that you're trying to assess, if it has any build errors, it is going to show it there. Right? It's not going to build it against .NET Core yet unless we port it. So right now it is not ported. So it is building it against .NET Framework version only, and it has 0 errors. Porting actions. This is interesting. And this is what we will dive deep into when we will do the demo of WCF application, right? So it shows that to resolve these errors, incompatible, there are overall 640 porting actions that needs to be taken,
Hmm.
either manually or it will be automated as much as it can be by porting assistant for .NET, that the tool. So it will try and like automate as much as it can. And when we'll see the Visual Studio version of it, we'll see that there are two types of error codes, PA0001 and PA0002. Uh, PA0002 means it is something that the tool can automatically update the source code. PA0001 mean that the manual intervention is required.
Right.
Right. So as I said, this is a complex project and it will overall require 640 porting actions. So when see, the typical problem with the project managers, or when we start with a new a project of modernizing our application, is that assessing that level of effort. We cannot give an estimate like it will take 1 month with 2 developers, or unless we have this kind of assessment upfront.
Hmm.
A lot of time what happens is that we go on a guess estimate, right? But this gives you a accurate level of information of okay, how much effort might be required. And then we drill down. So I'm going to drill down into this, and I'm not sure how again the font is, but I'll try and explain each and every portion of it for our viewers. So now this is the overall dashboard of the NOP Commerce in the drill down view, in which we can drill down and see uh, the more information about the incompatibilities, the pain points, where we need to focus our efforts on, and so on and so forth. The first assessment overview is again this similar summary. Uh, that is like 52 are incompatible NuGet packages out of 56. And this kind of bar shows that how well you are. So while you start porting, right, if you port like let's say few of the projects, this bar is going to show an indication about how well are you doing or how far you are from your success. Similarly, incompatible APIs and the build errors and porting actions. Right, for any of this information, you can just click here and it gives you a bit of information about what exactly these are. Right, whether it's porting actions, the number of porting actions in the SS solutions. Right. Now then we have multiple tabs here, which shows information with different pivot angles. Right. So first is the projects. Like as we said, there were 35 projects. So it lists all the projects. So now we know that the number of incompatible packages are 52 out of 56 at a solution level. But if you would like to look at the project level, like for example, nop.web, it is using 38 packages, out of which 36 are incompatible. So now we are able to see at a project level the information. How many projects is this particular project dependent on? It is dependent on 4 projects. So if we modernize this and the dependent projects are not modernized, then it might not work. Right? So for example, nop.core, it does not reference any project. So probably this might be a right candidate from where we can start the porting. Right? And then we can start putting other projects which are dependent on these, because the core module is proven. So this helps in overall planning, with the timelines. Okay, let's start with core and let's see how difficult like core is there. So to assess the effort for the core, right? The number of incompatible packages are just 7 compared to like overall 52 incompatible packages. There are only 7 that are here. So it will be easier probably to resolve. It will give the team the confidence also to okay, we are able to progress. Incompatible APIs are 26. The number of porting actions are relatively less, like 8, compared to if we see knob.web, right? It is 169. Right, so that's the level of information that we have. And yeah, as I said, it's a standalone tool, not a great UI that will not be able to like kind of a top and tail on this. But yes, we can like always what do you call sort stuff based on whichever parameter you would like.
Yeah.
So all of these are .NET Framework 4.5.1 as of now. Okay, so that's on the projects. Now, if we move to project references. Now, this is a project dependency graph, right? So what this helps is in visualizing all the projects and which depends on what, right? Here, we did show that with the numbers, but this shows it in a better way, like how would like, so you can always, look into it. For example, nop.core, all the projects are coming into it. None of the projects are going out of it. For example, NOP data, all the projects are coming into it, right? So you might think about, probably NOP.data is a better place to start than NOP.core, because there are less number of projects that are depending to it.
Yeah.
It will depend upon the strategy which the teams would like to take on how they would like to start, right? And again, you can always start inside out or outside in. It totally depends upon how you'd like. So generally what happens is that you have a specific application and you keep developing that application, though there is a parallel team which starts modernizing it, but the current release keeps on going on. That makes it a bit more difficult, right? So though knob.core is being modernized, but there are more features that are being added to knob.core framework version. So we need to balance that out. So yeah, this particular shows the dependency graph, and this is one feature which is not available in the Visual Studio extension in the developer environment, because that is more developer friendly and does not have this like a web a GUI or like this kind of graphs. Going to NuGet packages. Now we know that overall there are 56 NuGet packages, and a lot of them are incompatible. Right now, it shows that each NuGet package, how many projects it is being used in. For example, in AutoFac, it is being used in 13 projects. So if we are going to resolve this NuGet package, we are able to resolve issues in 13 projects for this particular package. Right? The number of source files it is being used in, it is being used in 17 source files. The current version is 3.5.2 of this particular package. It is incompatible, right? But we have been able to suggest a replacement that if you upgrade AutoFac to 4.0, then that will automatically become compatible. So we do have a huge data store in our GitHub, and that is open source, in which we have all these recommendations, inbuilt of, okay, if depending upon what kind of NuGet packages are, and and what version of those are compatible with .NET Core. So what happens was that all these NuGet packages, they were developed along with the .NET framework, so the previous versions are not compatible, right? But when .NET Core came, these NuGet packages also upgraded to support .NET Core. So it might be a simple matter of upgrading to the suggested replacement.
Right. Yeah, that's cool. So looking at the line below, for instance, then autofac.mvc5, which doesn't have a suggested replacement. What does that mean instead then?
That means that this particular NuGet packages cannot be upgraded to resolve the issues, or even if it is there, porting assistant does not know of it. If someone knows it, they can always raise a pull request, and based on the information, that is why we have this share the usage information. And when we get this kind of information that okay, somewhere a developer has been able to upgrade this to a newer version, it worked, we add it to our overall data store. But yeah, at this moment, it means that either this does not have an upgrade version, or porting assistant is not aware of it. And it means that there might be a manual action required. And we'll talk about that in the source file. It means that there might be an alternative that you'll have to use. It's not that it can be a what do you call automated upgrade, right? Again, similar stuff. We can always sort it by these. For example, like Microsoft ASP.NET MVC, it has been used in 32 projects, right? Out of the overall 35 projects, 32 projects are using this particular DLL, and so on and so forth. Moving on to the APIs. Now that was pivoted based on NuGet packages. This is pivoted based on APIs. Again, similar information, right? How many source files it is being used in, how many calls it is being done, like for example, accept verbs. This is part of this particular NuGet package. There are 5 source files which is using it, and it is being called 6 times. And again, it is incompatible, right? And we do not have a lot of suggested replacements for these. Yeah, so there are few for which we have suggested replacement, but quite many of them might not be having the suggested replacement. So for example, this XML read element string, right? So instead of read element string, the replacement is read element content as string. So this is the new API in .NET Core. So .NET Framework API meant read element string, but now it has been renamed to read element content as string. And that suggested replacement is something that, yeah, so these are compatible because just change of this, which can be done automatically by the porting assistant, and you are good to go. Cool. Okay. Source files. This is interesting. It shows all the source files along with the incompatible APIs. All right. So what I'll do is that I'll probably go with someone which has a lot of incompatible APIs. Yeah. For example, PayPal direct payment processor, 41 incompatible APIs. Right. If I click here, it shows the code. Right. And it shows exactly that this particular method is incompatible and it cannot be invoked. So at a line level, so in the source code, it shows at the specific line number level where a manual change might be required. So this helps developers understand, okay, that where exactly the errors exist and how they can do it.
Is that accessible in the Visual Studio plugin?
Exactly. So this is why, like the overall experience, we thought that instead of, like developers switching on between the standalone tool to find where the error is and going back to the editor and do the changes there, we thought we should be having this whole experience within the editor itself, Visual Studio editor. And in the Visual Studio, as generally the errors are shown, right, with a squiggly behind, beneath. So that is, we'll see it, depending upon how much time we have, in that this particular is shown there with a warning in the Visual Studio itself and along with the error.
It's cool.
Cool. That's on all the kind of features. I'm just looking if there is a, like where, no, it's all about incompatible APIs only, right? I'm looking if there is a example where I can show a manual, an automated code change that can be done. But we can see that, like during the demo of the WCF. Yeah. I think we are halfway into the session, right? So yeah, good time for us to start focusing on WCF.
Yeah, so you can start prep for that. And in the meantime, everyone, if you just joined us, this is the AWS Nordics Office Hours with me, Gunnar Grosch. I'm joined by Prasad today, and we're looking at modernizing legacy WCF applications using Porting Assistant for .NET. And Prasad has just done a walkthrough of the Porting Assistant for us to look at well, an example solution that he has assessed. And now it's time to do an assessment from scratch. And if you have any questions, just post them in the chat and we'll do our best to answer those.
Cool. So while we start assessing WCF application, so WCF is a specific type of .NET application. It is Windows communication foundation. Let me first browse through it. Okay. So I have this folder. What I'll do is that WCF demo. I'm going to use let me clone the project here. Ta-da. Give me just one moment.
I'm not sure if you mentioned that, but the WCF support in Porting Assistant, that is very new.
Right. So as I said, WCF is a specific kind of .NET application. When we released Porting Assistant, we were supporting more of ASP.NET applications. But we got the feedback from the customers that, a lot of their legacy applications involve WCF, which is a way to create applications. It's a more of a remote procedure call applications, which is done via WCF, but it is very tied to Windows, right? So if they have a WCF application, then moving them off Windows is even more difficult, right? So for that, there is a open source, initiative going on called CoreWCF, which is again by .NET Foundation, and AWS is the second highest contributor to that project after Microsoft. And CoreWCF allows you to modernize your WCF applications to CoreWCF and run it on Linux. Now porting assistant and that CoreWCF went to GA in February this year. That was initial release, and they have been enhancing. So right now the released version is 0.3. We have not released, we have not reached a 1.0 major release yet for the CoreWCF. But that's when we thought it is the right time for porting assistant to start supporting WCF application modernization to CoreWCF. So we released it like last week. So let me, I'm just taking a sample WCF application from the Microsoft GitHub here. And what I'll do is that first, so there are a lot of, like when it comes to WCF, as I said, it's a communication protocol, right? So there are different types of bindings. There are different types of, like security protocols that are there. So we'll use a TCP instead of a, like basic HTTP or IIS. So we'll use TCP here to showcase the overall demo. So let me open it and first go through the solution for a moment. And I'll run it on the .NET framework, and then we'll assess it via porting assistant.
Right.
Let me just drag my Visual Studio onto the screen. Okay. So as I said, the simple project, there are 3 simple solution, 3 projects in it. The first one is a service library, which is more like a definition of the, like the contracts. Let me open it and show that, and let me see if I can increase the font. Is this better? Font wise?
Good. Yes.
Cool. So it has like 2 contracts, get data and get data using data contract. And we have a specific, like a type of class, like it's not using the primitive type, but a composite type class, just to demonstrate, right? And when it comes to the implementation of that interface iService, the get data does, like just it, if you provide an input from the client, so it's a remote procedure call, a client will call the server, client calls the server with a specific value, and it just simply, like returns you entered this particular value. Similarly, for get data using data contract, whatever input we are sent, it uses, it appends that string with from WCF service hosted in Windows container. As I said, .NET WCF is tied to Windows, so you can containerize only to Windows containers. But when we port it to core WCF, we can containerize it to Linux containers too. Cool. So that's on the service library. We'll come back to the client, but let's look how it is hosted. So it's a pretty simple stuff. The service host uses the service host. It's an internal API for service 1, which is what our service was. It opens, and as soon as the host is open, it starts listening on the particular port. And when we, as is a sample, and if we press enter, it is going to close the host. Where exactly it is listening is defined in app config. So this is where when we create an object of a service host, this is the app config that it generally takes. So which binding it is. The binding is net TCP binding, the behaviors of the service, right? And this is the addresses, like, it works on localhost 81. Cool. So what I'll do is I'll run this. We'll see a quick demo first on the .NET Framework side of that. So let me start this and see which window it's going to open. Yep. So here it is. As I said, simple console application, and it says that the service is ready and it is listening now, right? What I'm going to do, I'm going to detach it so that I can run the client on the same instant. So I'm going to detach it. Now let's talk about the client. So I still have the service running. It's in the background. I still have this service running, right? Now client is going to call this service, right? For that, so we have this WCF client, service client, and it is calling that particular API get data with this value 456, and then calling the other with the values hello WCF TCP client, and the bool value is true. It's a simple, client which is calling the service with these values. So if I run this, and I bring this again here, it will show that it has been able to communicate to the service and has been able to get the response. Okay. It went into the break mode. Great. As always, continue execution. Nope. Let me rebuild it and see what's the issue. That's for the service because service is already running, but the client should be fine, right? Yep. So if I rebuild the client, cool. So now if I try and run it again, let's see what is the issue. Yeah, okay, it's working.
There we go.
Right? So yeah, I'm not sure. Again, let me see if I can increase the font of it. Yep. So it says that it's been able to call the service and we got the response from the service and the client is displaying it. So it's kind of, like in the modern world, now we are using all REST APIs, right? But this is what it used to look like a decade ago. And, this has been used very widely, very widely. Like I have built multiple applications using WCF because, when the time, so in initial remote procedure call in .NET was known as .NET remoting. That was using SOAP and XML. And then Microsoft came up with WCF, which we are looking into right now, right? And now the overall world modernized to, like REST APIs and then GraphQL and, like gRPC. But there are applications which sit on these. And there are, like companies who actively, update these applications because rewriting them again in the newer framework would be very difficult, right? And that is why modernizing them in an easy manner to core WCF would be a great option for those customers, right? So that's on the solution. So let's go back to our porting assistant and see how difficult or easy it is to, like port this application, right? Okay, solution file name required. I think I had it open here. Yes. So if I go here, TCP self-host, and I'm going to select this. So I provided the solution file of that particular application and click on SS. And as you see, like it has started assessing this particular application. So depending upon the complexity of the project, it may take several minutes. This particular project has like 3 projects, not much. Like NOP Commerce takes much more time because it is a quite large, complex project. But this has only 3 projects in it and not many source files. So hopefully it should take less than a minute. But yeah, we'll get to know right now.
And using Porting Assistant, is there any cost associated with that?
No, Porting Assistant is a free tool by AWS.
It was a leading question from my side. All right. So the one you showed us before, how long did that take to process? The NOP Commerce one.
It took, on my machine, it took around 15 minutes. So now this is done. Like, yeah, roughly around a minute, we can say.
Yeah.
Again, if we look into the stats, so there are 3 which are not ported. There are no packages which are incompatible. There are APIs which are 8 out of 26 which are incompatible. And there are 4 porting actions. Right. So I've kept this, like a particular solution quite simple because I want to show more of the WCF, how it is being modernized rather than the general business logic code files, right? So we'll look into that. Now, if I go to WCF, yes, again, we have all this information like at the project level, at the project references. So if you see project references, as we saw, right, client in itself is an independent one. And we had this service library and it is being hosted by the self-host. So we have just 3 projects. This self-host depends upon service library and client is independent. NuGet packages, there are no NuGet packages that are being used. It's all APIs, which is, WCF APIs that are being used. There are few which are compatible. There are few which are not incompatible. I think there would be suggested replacement for few of them. Like for example, this, it says this part of WCF won't be ported to .NET Core. We can look into here. And this is where probably a little bit of manual intervention would be required, right? Again, the source files level information is here, right? So what we'll do is that we'll port this project. And again, to port, as I said, we can either click one of them and port the specific project. We can select all of them, right? Like from here, select all of them and port all the projects or multiple projects. Or we have this option of port solution here, which is same as, like selecting all the projects and click on port project. It's like either select, yeah. So I'm going to click on port project, selected all. Now this is where it says that when we port the application, where do you want the application to be saved? The ported one to a new location or modify the source in place. So if it is in a version control, you can always choose modify source in place, right? It's better ways to cut a branch and then do the porting in it, so that then you can see the changes of what changes has been done automatically, right? So as I know I cloned it from the Git, I'm going to use modify source in place and we'll see the changes that were there. Click on save. This shows that, like, okay, the new target framework version is .NET Core 3.1. This is the port destination, which is the same as the source file. And these are the current framework versions. And once you're happy with it, click on the port. Now, as you see, it started porting. It may take a few minutes. Again, it should not take a lot of time, but yeah, we'll give it a minute or two for that porting to happen.
And everything now, that happens locally on your client?
Yes, the porting happens locally on the client. It does communicate, with, to get few information about the assessment and the manual actions, the automated actions you need to take. So it goes, if so, let's say, if it find a particular pattern which is able to change it. So you have to go to the repository to find what is the target code that I need to replace this source code with. It fetches that and changes it on the local. So it happens on the local, but there's a communication going on. Cool. So porting is complete, but it is after the porting, it started assessing it again, because once you have ported it, obviously the stats would change. So it is going to assess this particular project again.
And what do we expect the outcome to be this time then?
So it should show the ported projects should be 3 out of 3 because we have ported all the 3. Now, then it should show the incompatible packages and the APIs, and in case if there are any build errors. As I said, I've chosen a simple one, so it will not be having a lot of build errors. But what we will do then, okay, it is complete now, right? So ported projects is 3. If you remember incompatible packages, there were 0 packages that were being used initially, right? But now we have used 8 of them. So like WCF do not use kind of packages, but now we'll see what kind of packages we are using here. We have core WCF packages, which we'll see in the project files, that has been included, and all of them are compatible with the .NET Core. Incompatible APIs, there were 8 initially out of 26 which were incompatible. Now we are using 36, and only 1 of them is incompatible. No build errors, and all the porting actions has been done. We can dive deep into it here. But what we'll do is that, in the interest of time, let's move to the Visual Studio, right? And as it has changed the projects, right? Now the project was initially targeting to .NET Framework. Now it is targeting .NET Core. So it'll ask us to reload all the projects. So I'm going to reload all the projects. And let's look into, so if you see, these are the changes, yeah. Is the font good enough to show this, because
it's a bit small.
The font can be changed for the source code and not for this particular. So this is a Visual Studio, right? So, but anyways, let's look into the Git changes. It shows all the changes that has been done. So first, if we talk about WCF library, right? So what it has done is that all the files which are not being used, it has deleted them and created an archive of those. So this is like, these files are not being used anymore in .NET Core version of them. The second is there's a modification on iService. Okay, so let's see this modification. All it has done, if you see, it has replaced system.service model with CoreWCF, right? So this service model namespace is being used in your, older versions. CoreWCF is being used in the newer version. So this particular change has been done automatically by the tool. So developers need not go to each and every file and make this change manually. Rest, it is same. It has just done some formatting, actually. It is the same code, but there is no specific code change that has been done. So, but that's one thing that I wanted to show, that the namespace change is being done automatically. It identifies the right level of namespace and changes it. Now, which version of namespace? Like there were suggested replacements, right, that we saw there. So which version of namespace is we can see in the csproj file. So on the left-hand side is the project file, which is targeting to .NET Framework. And you can see it is a quite long file with a lot of information. So Microsoft simplified the overall project file greatly in the .NET Core version of it. Okay, so it's better to see that not in this comparison manner, but probably directly the source file of the newer version. So this is how the latest version of project file looks like. .NET Core 3.1, and then these are the NuGet packages that are being used, new NuGet packages, CoreWCF, and then it is being exposed as ASP.NET Core. The version star means that whichever latest version is there, pick it up. So that's the latest stable version. You can take it up. Cool. So that's on the changes on the WCF library, and it is 100% compatible. Now let's talk about WCF self-host. Right. So if we start looking changes here in the WCF self-host project, again, the assembly file has been deleted and archived. App config file has been deleted and archived. The information that was there in app config is actually moved to CoreWCF ported.config. So this is the new, like how it looks like in the modernized world of it. It shows the address point is service 1, net TCP binding, configuration, and the contract is WCF library 1, iService 1. Right? And this is where a small change, code change is required, right? Mainly because you need to give the full path, a code change is required here, like manually. Now this is being identified, and this might be added as one of the repeatable patterns, and it's going to do that, the porting tool. This is one small code change that we did manually in the ported file. Now let's come to program.cs, right? If you remember, in the older version, program.cs had this service host, which was creating. And we used to do a host open and host close to actually start listening on a specific port. But now, and I'll show the new version of it rather than showing in the changed version, because it is completely different. So there's no point in changing, seeing the changes, right? So this is how it looks like. If I format it, control key. Yep. So ASP.NET Core developers would be like more familiar with this, that it creates the web host builder with the net TCP and uses the Kestrel. And now it shows that it is being listening on 8,000. So the overall the mechanism of listening on a specific service source has been changed to use the web Kestrel ASP.NET Core stuff. And it uses the startup. And if we go to the startup again, ASP.NET Core developers would be able to understand this, adding the service model, configuring services, and using that service model. And if you see this service model, it is being, like the path to XML. This is the XML that is the latest version of CoreWCF ported config, which we saw in changes. This is another place where you might want to make the changes. Instead of giving this absolute path, you might want to give a relative path. Like, if you're containerizing it or you're having it, in your specific configuration, this might not be the best way. But yeah. So that's on the changes on the self-host part, right? So let's try and run this now. And then we will deal with the client.
All right. We're closing in on top of the hour as well of this episode. So while that is building and running, if you have any last questions, just put them in the chat. See if this...
Okay. So now it is listening on this particular port. Application started.
Yeah.
So now, but this application is CoreWCF, so you can run it on Linux also. So that's the beauty of it. Now you can containerize Linux containers and run it on, Linux containers. Now let's see what changes were done in the client and how we can do that. So again, from the project files changes, if we look into it, we have added the service model and package references. Okay, this particular part is being used by porting assistant as commented. It's only used while porting. You can always delete it if it is not required. Right now program.cs. So it was not able to make any changes to the client. And remember, there was one porting action that was showing. So that was for this particular code file actually, change. So what I'll do is that I'm going to change that to the newer version of CoreWCF, which is mainly to connect to this new port, right?
Yeah.
So
and this is basically what you would do when you're porting an application. You'll find those actions that the assistant isn't able to do, and you'll figure it out yourself.
No, that's what it shows in the here. This is where it will show you, right? Incompatible APIs 1 of 16. So it helps you overall understanding where exactly the problem is. So if you see program.cs here, it clicks here, it shows that this is where the problem is. So it gives you an idea. Now actually I've changed this, so that is why it is showing that it's there. So it gives you an idea of which source file to target, which line number to target. Right. So now this uses a new namespace. So we're going to use that namespace, and now all done. So if we see this particular, service which is running, right? It is running on this particular port. And that's why in the service client that we are creating, we are saying that, we are going to connect to this endpoint address and then again call the same contracts. So I'm going to detach the service so that I can run the client here in the debug mode. Right click, debug, start new instance. Okay, so other point. So it says that the project type now is class library, and we need to run it as a exe. So we need to change the project type. So right click, projects. Oh, not projects. Properties. Yeah, properties. And the output type needs to be a console application. Then let's save it. Then right click again, debug, start new instance. Now this should be able to communicate with the service and get that data. So yeah, so it has been able to communicate with the service. Let me increase the font size. Oh, too big, but yeah. It was able to communicate with the service and able to get the data. So the whole application remains as it is. Porting assistant did a lot of changes automatically, few manual actions, and we have been able to port the WCF application to CoreWCF. And yeah, that's frankly the end of the demo from the standalone tool.
Very cool. And that brings us to the end of the show as well. So any last thing you want to mention?
Yeah, from the developer experience perspective, you can always use Visual Studio. So in the extensions, you can always install Porting Assistant extension. And instead of doing assessment and porting from the standalone tool, you can do that from here, run full assessment, port the solution, port a specific project. So you can have that experience from within the Visual Studio itself. The errors that we are seeing that can be seen here in the error list in the warnings. So like in this warning specifically, we'll be able to see all the porting actions that will be required.
Very cool. All right. And with that, Prasad, thank you very much for joining us today. We've had a look at how to modernize your WCF applications using Porting Assistant for .NET. So thank you very much.
Thank you, Gunnar, for having me.
Right. And thanks to all of our viewers, and hope to see you again next week. Bye-bye.